I hope everyone's doing well. I'm Mr. Ish. Thank you for joining me for this video where we're looking at the acidity of the terminal alkyl hydrogen. What is this alkyl hydrogen? If you have a certain carbon, there's a hydrogen at the end of that molecule. That's your terminal alkyl hydrogen, and it can be acidic based on a variety of factors. Consider here this first point. The electronegativity varies with hybridization. You know, here with hybridization we're talking about sp3 versus sp2 versus sp. As the hybridization changes, the electronegativity of your specific atom will also change, and electronegativity can impact the acidity of that alkyl hydrogen. Consider this point number 2. Electrons which are in the s orbitals are more strongly attracted to atomic nucleus than electrons in p orbitals. The s orbitals and the p orbitals, you know the difference. P orbitals will more likely exist as above and below a certain bond in terms of clouds. The s orbital is more likely involved in the sigma bonding, which you see direct atom to atom bond. Lastly, atoms with high s character, high s orbital character, is more electronegative. As you're looking over here from sp3 to sp2 to sp, you're seeing an increase in s character in the direction of sp. And why is there an increase in s character? Because if you have 4 items here, s is 1 out of 4, it's 25%. If you have 3 items here, 1 s and 2 p, s becomes 1/3 in terms of character. If you have sp, you have 2 items, s is 50%. So you're increasing in the s character. Therefore, this will be an atom having an sp involvement in terms of bonding will have more s character, and therefore it will end up being more electronegative. But let's look at all of this with regards to the terminal alkyl hydrogen using our basic examples that I'll present. Look at these 3 examples: ethane, ethene, and acetylene. Single bond, double bond, triple bond. This right here is sp3 hybridization, this here is sp2, and this here is sp. When you're looking here in terms of s character percentage, you know what this is. This is 1 out of a total of 4, it's 25%. When you're looking at this is 1 out of 3, this is 33%. When you're looking at this is 1 out of 2, this is 50%. So you know the s character is increasing as you're going down, which means that this right here will be your most acidic hydrogen with regards to the terminal alkyl hydrogen. In regards to acidity, these are not very acidic, but in terms of organic chemistry, this is relatively acidic. And I can even separate this for you and make it 1 as H, 1 as H here. This is less acidic, and then we can also demonstrate this only on one side. Here's H, here's H, here's H. This is your terminal hydrogen. Any of these are your terminal hydrogens, but I'm only marking one. This is the least acidic, this is the next more acidic, this right here is the most acidic, only because you have the s character increasing. If you were to look at the electrostatic potential map based on those 3 factors I was talking about, if you were to look at it, because this atom here, carbon atom here, has a high s character due to sp hybridization, the electronegativity depending very much on the hybridization involved, this becomes relatively more electronegative. Because it is more electronegative, you can say it has a relative negative character. This hydrogen has a relative positive character, and you have a sucking of electron density away from the hydrogen towards the carbon, which is sp hybridized. Hence, because of the direction of this terminal alkyl hydrogen becomes more acidic, and it can be deprotonated by means of a strong base. In the presence of a strong base, if you were to do the reaction, you would have this: an acetylid anion would develop, a acetylid anion, because the strong base would have plucked off this terminal hydrogen, which has a certain acidic character to it, and this right here becomes a basis of reactions and or nucleophilic reactions, because now you have something which is a nucleophile. You have a pair of electrons available for some sort of bonding to propagate and or develop other bonds. When you look over here, you don't have much of a strong electronegativity pull at all. These are relatively equal in terms of electronegativity, hence you don't have that a partial negative here and a partial positive. You won't see it as strongly because everything here is sp3 hybridization. You will see to a certain extent that here you have sp2 hybridization, here you have partial negative, and these are partial positive, but it still will never be as strong as this. Here this is significantly electronegative, this carbon, because of sp hybridization. The fact that you have a large number of electron densities stuck right here in this area, it is giving the carbon negative aspect, hydrogen a positive aspect. This right here is significantly available in terms of being plucked off by a strong base. What you want to remember here is as you increase the sp hybridization, as you're increasing it, the terminal hydrogen is becoming increasingly, and these are the terms you want to remember, as the sp hybridization increases, the terminal hydrogen is becoming increasingly positively polarized. And what does that mean? It's becoming increasingly positively polarized. It can be plucked away because it is a partial positive character, and making it acidic, it can be deprotonated. Hydrogen is becoming increasingly positively polarized when found in a molecule which has a relatively high sp character, especially when it's bonded to an atom with a very high sp character. That terminal alkyl hydrogen becomes acidic. What are the relative acidities of these in terms of pKa? I'll post that out for you, and then that'll be the end. When you look at the relative pKa values, they're not very strong in terms of real acids, mineral acids, or inorganic acids, but in terms of organic acids, it's noticeable. You have over here a pK of 50. Here you'll have a pK around 44. Here you'll have a pK around 25. You'll see in terms of the comparison 50, 44 to 25, it's a significant drop from 50 to 25 simply because the hybridization has changed. It's twice as strong in terms of acidity, that terminal alkyl hydrogen, for an sp hybridized atom that is bonded to. And that right there is the end of this video. Thank you.